Alright, I think we left off on number 3. Okay, I think we tried a couple of these. So, I mentioned yesterday, okay, that it's a good idea to start by marking the given information on the diagram. So, I'm giving QS. That's given, right? First line is always the given information. Well, then how do they conclude that PQ is equal to TQ and U lengths are equal, then the segments are congruent? Then how do we claim that PQ plus QS equals PS and TQ plus QU equals TU? Well, so we can only use this equals PS, right? We're just saying this piece plus this piece equals the whole thing. Yeah, so if we, bless you, if we, how about the next one? How can I claim that, yeah, that's going to be substitution again, right? We're just looking at this second statement here, replacing QU with QS. And again, we're allowed to do that because up here we claimed that UQ or QU, same thing, QS. So I'm allowed to substitute one in place of the other. How then can we claim that PS is equal to TU? Well, so our final line will be definition of congruence, because we're just saying the lengths are equal, that the segments are congruent. But how can I first just claim that the lengths are equal? It's not going to be symmetric property. Katie? We could use substitution again, right? If I look at these last two lines, right, we've said TQ plus QS is equal to PS, and then that same thing, TQ plus QS is equal to TU. Okay, so we could say, well, I'm going to substitute PS in place of this TQ plus QS. So it could also be transitive, right? Because we're saying both PS and TU are equal to the same thing, therefore they're equal to each other. Okay, so we could put substitution or transitive property here. I'll put transitive since we already used substitution a couple of times. And then the last one, Summer already told us, since I'm just saying the lengths are equal, therefore the segments are congruent. That's the definition of congruence. I'm sorry, say that again?
Like, if you said, like, the angle
Like which angles?
like, both people do the same. Do we ever do, like, reasons for that?
Oh yeah, the next section is angle proofs. Yeah, so we'll prove that, maybe certain angles are congruent or certain angles are a linear pair or something like that. Yeah. Questions? Do we feel like we can try one? Or do we want to do another one together? There is a whole bag. That's why this is a 2-day lesson. Alright, so why don't you guys see how you can do with number 4 here? Okay, go ahead and try number 4. Okay, we're given a few pieces of information, right? So see what you can figure out here from this given information. All right, let's take a look at number 4 here. So I'm given a lot of information here. I'm given that K is the midpoint of JL, and M is the midpoint of LN, and JK equals MN. Okay, so first, these two statements about the midpoint, obviously that's given to us. Well then, from that, they conclude that JK equals KL. So we're saying if K is the midpoint, JK equals KL. So I can mark that on the diagram, right, saying that those have the same length. And also, LM and MN have the same length. So I can mark that on the diagram. Why can I say that? How can I conclude that? And for number 2, how can I say that JK is equal to KL and LM is equal to MN? Yeah, definition of midpoint. Right? If I'm told that a point is the midpoint, then I can claim that each half of that segment is the same. Okay, now I think number 3 messed with a lot of people. Okay, we're given number 3. Right? We're given JK is equal to MN. So in this case, since we were given a bunch of information, they said, well, let's take the first part, figure out what we can conclude from that. Then we'll take the second piece of given information and figure out what we can conclude from that. So there is actually another given line in this proof. So then they say, well, I can now claim that MN and KL have the same length, and LM and MN have the same length. How can I state that? So we could use substitution, right? If we look at these two statements, okay, we're saying that JK and KL have the same length, and then JK and MN have the same length. So what we can do is substitute. Let's see, they would have substituted MN in place of JK there. Okay, since I know that those two things are equal, to say that MN is equal to KL. Okay, could have also said transitive for that one. Transitive would also work. Then how about to go from line 4 to line 5? We could use transitive again, right? Because we're saying both KL and LM are equal to MN. They're both equal to the same thing, therefore they're equal to each other. So yeah, you could also use substitution for this one. Well then, if I know LM is equal to KL, how can I claim KL is equal to LM? It's symmetric, right? All we did was flip these two things across the equal sign. So that's symmetric property. And then finally, how can we claim that KL is congruent to LM? Definition of congruence, right? If I already know the lengths are equal, I can claim the segments are congruent by the definition of congruence. Starting to feel a little bit better? Slowly, okay. On standardized tests, like the air test at the end of the year, most of the time you will see a proof like this or proofs like the first couple on the back where you have some of the proof filled in, okay? It's basically impossible to grade a proof where you do the whole thing yourself on a standardized test, okay? So we will probably focus more on proofs where you're filling in pieces, okay? But we will definitely do some where you have to write the whole thing yourself, okay? Where you're not given any statements or reasons, right? Those, I think, require a good amount of processing and thinking, okay? But because these are the type that show up on standardized tests, we'll also spend a decent amount of time on these, all right? So why don't you guys try both 5 and 6 here? Okay, go ahead and try both 5 and 6. Sure.
So yes.
I probably should.
I did
Yeah. Yeah, that would work. Alright, I think most of you are close to, if not done with number 5. Okay, so take a look up here at what I have for number 5. Okay, so obviously the first line is given. Then all they did was say, well, if the segments are congruent, the lengths are equal, so that's definition of congruence. Then they used the segment addition postulate to say xy plus yz equals xz. Same thing for this segment. Then they used substitution, right? Since I know that xy is equal to uv, they just substituted that right here. And since I know yz and tu are equal, they substituted that right here. Right? Then they said, well, if I know that uv plus yz, same thing right here, those are equal to xz and tv. Okay, so if those two things are equal to the same thing, they're equal to each other. So that's transitive, or you could have used substitution there. Both would work for number 5. Then, if those lengths are equal, segments are congruent. Definition of congruence. On the state test, most of the time, it'll be like a drag and drop thing, so you'll only have one or the other option. Any other questions? Go ahead and keep working on number 6 then. Give you guys another minute to finish that up. And we'll take a look at the back.
Wait. No, that's those parts. Yeah, no, we get wrong. Yeah, there's only one answer. So that means there's two. Not all of us are. Not all of us are. That's the meme. You're out. You're out. I support that. I'm not sorry.
Yes. Number 5 was the same addition postulate. For number 5,
Why not giving you the whole line?
Well, the only thing that changed from line 4 to line 5 was XZ to VW, and I don't think anywhere we already claimed that XZ was equal to VW.
So next one's like
Wouldn't it be what? Yeah. Or substitution.
and the last one's
Yeah.
yeah. No, actually, well, wait.
Alright, take a look up here at number 6. Guys, see how you did. gonna get there.
Now,
We're
can
gonna
we
do that.
go back to our
All right. Any questions on number 6? Feeling okay?
Oh, shoot.
All right. So on the back then, okay, the first 3 proofs on the back, we have some statements and some reasons missing. Okay. So we need to fill in some missing pieces for each. So let's do number 7 together here, and then I'll have you guys try. So yeah, so we got to put in some statements on this, but we're given the reasons for it. Okay, so I'm given a couple of pieces of information here. Right, I'm told E is the midpoint of AC, and DE equals EC. So the first statement is just E is the midpoint of AC. What's my reason? Right? Well, now they tell me the reason for the second one is the definition of midpoint. So what can I conclude from this by the definition of midpoint? AE equals EC. Okay, and we should, I guess, be marking this on the diagram. Right, so AE and EC have the same length. D have the same length. Right, so I'm told this is the other piece of given information. Right, so this would be DE equals EC. Okay, well the next one they conclude that AE equals DE. How can I claim that? We could use substitution or transitive. Either of those would work. So next, we have to fill in the statement, but they tell me the reason is definition of congruence. So what would I claim if I have this statement, AE equals DE, what would I claim by the definition of congruence? Okay?
AE and DE with the line over it equal each other.
Yeah, so I can say that these are congruent to each other then, right? Well then, they say that DE is congruent to AE. How can I claim that then? Symmetric graph, right? All we did was flip things across the congruent sign. Feel okay with that? Certainly not all, but I would say more than 50% of the proofs that show up on the air test are in this format, where they have a few missing statements and reasons. Okay? Some of the time it'll be like the front. Okay? Some of the time, but I think more often it'll be something like this, okay, where you've got missing pieces on both 8 and 9 here.
What do you do for grade?
So this one, we actually just do arguing about this as so yeah, here. So
Equals what?
two sides of that equation.
Property substitution. What do you do to 5? No.
I know.
All right, let's take a look at number 8 here. Okay, this one is a little bit different than the last few we've done because we have to think about some of these more as an equation than the geometric properties we've been using, right? So we're given RS is equal to 1/2 of RT. That's all we're given. Well, then they claim that 2RS is equal to RT. Well, what we did here is just multiply both sides of the equation by 2, right? We can do that. We can multiply both sides of a geometric statement by 2 like that. So that's the multiplication property. Well, then they tell me the reason is the segment addition postulate. So that would be RS plus ST equals the whole thing of RT. Well, then they claim that 2RS is equal to RS plus ST. So they're saying, well, both of these things are equal to RT, therefore they're equal to each other. Then, from this equation, they subtracted RS from both sides. Okay? So then we would just get 1RS equals ST. That's the subtraction property. And then finally they tell me the reason is definition of a midpoint. So I know that my final line should just be what I'm told to prove, that S is the midpoint of RT. Okay?